Okay, number 7, we want to consider the following machine that accepts inputs as ordered pairs. Suppose the component of the ordered pairs are positive real numbers, and the first component is the length of the rectangle, and the second is the width. The machine computes the perimeter, the distance around the figure. Thus, a rectangle whose length is 3, width is 2, the input is 3, 2, and the output is 2 times 3 plus 2 times 2, or 10. We're going to complete parts A through C. Okay, so for the following inputs, 1, 7, 6, 2, 2, 6, and the square root of 3, square root of 3. For part A, we're going to compute the output. So we're just going to do 2 times 1 plus 2 times 7, and that will give us 2 and 14, which gives us 16 for our first box. And then we're going to do 2 and 6 plus 2 and 2, which 12 and 4 also give us 16. And then the next one is just the reverse of 2 and 6, so we should also get 16. And then the third one, we have 2 square roots of 3 plus 2 square roots of 3. So we add just the coefficient out front. 2 plus 2 gives us 4 square roots of 3. So 4, and then we need the square root symbol, and then 3. Alright, part B, find the set of all inputs for which the output is 14. So in order to figure that out, we're doubling both the numbers. So if you can add those two ordered pairs, any two numbers that you add, that gives you 7. So 2 and 5, 1 and 6. And you have to have two measurements, 3 and 4. Okay. Because we're doubling these, just to show you, if we did 2 and 2 plus 2 and 5, here's the math behind it. If we factored out or did the distributive property, this would be 2 times 2 plus 5. And so 2 plus 5 is 7, and double 7 is 14. And that's the goal that we want, 14. So you want to find numbers that add to be 7. And you can kind of apply that distributive property of math and kind of see what's going on there. So we want numbers that add to be 7. So 1, 6, 2, 5, 3, 4. Those will work. We don't want to use 0, 7. It would not make a rectangle. You would just have a line, a length of 7, and you wouldn't have any width, so that would not give you a rectangle. We have to have some dimension. So that would not, 7 times 0 will give you 0. We have no area, so no rectangle there. So you don't want 0, 7. We could reverse those orders. So 1 could be the width, 6 could be the length, 2, 5, 3, 4. We could also do 4, 3, 5, 2, 6, 1. So for all possible outputs, D is going to give us all of them interchanging the length and width. This would just give you the possible combinations. And then part C, what is the domain and range of the function? So domain and range just lists the x, the first coordinate, and the second coordinate. So domain and range would be both 1, 2, 3, 4, 5, and 6. Those are the numbers we use, and these were paired with 6, 5, 4, 3, 2, and 1. So if I use 1 for width, 6 would be the length, 2, 5, 3, 4, and so on. So this would be just a listing of your domain and range. So D for domain, R for range. So the pairing of these numbers, so this 1, 2, 3, 4, 5, 6, 6, 5, 4, 3, 2, 1. So The domain of the function, it says, is the real positive real numbers cross the positive real numbers. The domain and range cannot reasonably be determined because the real life limit. Domain and range is the set of ordered pairs that sum the coordinates is even. Okay, the domain and range of the function are all real numbers. Okay, so I was thinking it's based on the scenario. Let me see if there's some more information. So I was thinking just based on this part. So the domain and range, we would go with A is the set of positive real numbers. Positive including 1 and above. So A would be the best fit. This one, you can have a rectangle of any size, so it's not limited. And they don't have to be even because we just did one where they were odd, added up to be 7. So A is going to be the best fit here.